Alright, so we finished example 1 in the last video. We're going to now look straight at example 2, where we're going to use the properties of integrals to evaluate each of the following, and I'll pull them up as we go through it, given that the integral from a to b of f of x with respect to x is equal to 8, that the integral from a to b of g of x with respect to x is equal to -3, and the integral from a to b of h of x with respect to x is equal to 5/2. So, example 2a, we're looking at just the integral from b to a of g of x with respect to x. Now that uses the second property from the list we made in the last video, which means that it's the opposite of the integral from a to b of g of x with respect to x, and we know that from a to b the integral is -3. So the opposite of -3 is 3. So our answer is 3. Let's look at b. We're taking the integral from a to b of 2 times f of x with respect to x. This one looks a lot like our fourth property from our list, which says we can take 2 times the integral from a to b of our function with respect to x, and we know that the integral from a to b of f of x is 8. So 2 times 8 is 16. So our answer is 16. Now let's look at c. c, we are finding the integral from a to b of 5 with respect to x. Now this is like property 5. So we're going to go and write this as 5 times a minus b. And if we knew a value for a and b, we would actually evaluate this. But 5 times a minus b is good enough for our answer right now. So part D, we've got the integral from a to b of 5 plus g of x with respect to x. So this now utilizes a couple of our properties. First, this is looking like property 6, so we can break it up and say it's the integral from a to b of 5 with respect to x plus the integral from a to b of g of x with respect to x. We just found the first part. We know that's 5 times a minus b. And then we already know the second part. That was given. So we're adding -3, so we can just write -3. So 5 times a minus b minus 3 is our answer to D. Let's look at E. E, we're looking at the integral from a to b of f of x minus h of x with respect to x. So we can write this as the integral from a to b of f of x with respect to x minus the integral from a to b of h of x with respect to x. And we know these two values. We know this first one is 8 minus the second one is 5/2. if we were to rewrite this, we can write it as 16 halves minus 5 halves, which gives us an answer of 11 halves. So the answer is 11 halves. Let's take a peek at f. We're taking the integral from 0 to 4, from a to 4, of h of x with respect to x, plus the integral from 4 to b of h of x with respect to x. Now we can write this as the integral from a to b of h of x with respect to x, which we already know. That's 5 halves, so our answer to f is 5 halves. So now let's look at example 3, where we are wanting to find the following. If the integral from 1 to 5 of 3 times f of x plus 4 with respect to x is 34, we want to find the integral from 1 to 5 of just the function, not all the extra stuff. So we're going to utilize those properties we took note of. So we can start by rewriting this 3. We can first, we can break up that addition. We can write this as the integral from 1 to 5 is 3 times f of x with respect to x, plus the integral from 1 to 5 of 4 with respect to x is equal to 34. Then we can take that 3 and bring it out in front of the integral. Rewrite this as 3 times the integral of 1 to 5 of f of x with respect to x, plus, how about we clean this next part up? We know we can write this as 4 times 5 minus 1. We subtract the bounds. Equals 34. Now 5 minus 1, that is 4. And 4 times 4 is 16. So we can rewrite this as 3 times the integral from 1 to 5 of the function with respect to x, plus 16 is equal to 34. Now we can subtract 16 from both sides. We're using basic algebra skills right now. So we've got 3 times the integral from 1 to 5 of our function with respect to x is equal to 18. We can divide both sides by 3 now, so we can figure out that the integral from 1 to 5 of our function with respect to x is equal to, well, 18 divided by 3 is 6. So we have finished example 3. Let's look at example 4. So moving into example 4, we want to know the following. If f of x is an even function from, and we find the integral from 0 to 3 is equal to 8, what do we think the value of the integral from negative 3 to f of x would be? And I'm just going to give this one to you. So in this case, the integral from negative 3 to 3 of the function that's even. Now, as a reminder, even means it's got, it goes from increasing to decreasing. There's, at a minimum, a picture might look like a parabola. So, which means we have an area and then another area. So if this is the case, they're both above, or in some cases the function might be below the x-axis, but in this case it's above because our integral is 8, it's even. We've got two even areas, so we multiply it by 2. So we just double the area. If we have an odd function means that there is either no turning of the graph, or it means there are an even amount of changes, like a cubic function. So in here, we've got a portion of the graph and another portion of the graph. Those are even, the same size. So from -3 to 3, the integral of a function that's odd, one portion's below, the other portion is above. Since they have equal amounts, the net area is going to be 0. So now let's check out example 5, which example 5 starts by saying, let's sketch the region defined by the definite integral and then evaluate the integral using a geometric formula, finding the formula for whatever area is represented. So we have the integral from 1 to 4 of x plus 3 with respect to x. So if we were to graph that, just create a rough graph. We're going to first, on our y-axis, go up to 3 and put a point. And then from there, we're going to go up 1 and over 1. So we're going to do that 4 times because our integral goes from 1 to 4. So we're going to go up 1, right 1, and we're going to repeat that 4 times. And then we can connect our dots. Now our integral is looking at the region from 1 to 4, so we are going to just block that off. So we know what portion we're looking at. So we're looking at this blue region, which if I was using graph paper, I would be much more accurate with this picture. Now this shape is a trapezoid, where we've got one base that is 3 units and another base that is, correction, that first base, I counted wrong. That base is actually 4 units. The other base is 7 units, and the height of this trapezoid is 3. So the area is going to be 1/2. In fact, let me go back a minute. It's going to be the 4 plus 7, the two bases, times the height, divided by 2. 4 plus 7 is 11. 11 times 3 is 33. So we can say the area is 33 over 2 square units. Now with part B here, and we could have also done this with the last example, let's start by breaking this up. Let's write this as the integral from -1 to 3 of 4 with respect to x minus the integral from -1 to 3 of just of x with respect to x. Because what we know is from this first half, we can write that as 4 times 3 minus -1, so 3 plus 1, which would be 4 times 4, which is 16. Then we're just going to minus the integral from this last part. Now if we graph the last part, we're graphing x. X goes through the origin and has a slope of 1. So from -1 to 3, if this is -1 and this is 3, we've got a triangle with, on the left side, a base of 1 and a height of 1. And on the right side, we've got a triangle with a base of 3 and a height of 3. So we're going to go base times height divided by 2 and combine them. So we're going to go 3 times 3, which is 9, divided by 2 minus, since the other part is below the x-axis, 1 times 1 divided by 2 is 1/2. Well, 9/2 minus 1/2 is 8/2, which is 4. So we're going to have 16 minus 4, which gives us a total area of 12 square units. Let's look at the next two examples, C and D. So with C and D, we're going to do the same thing. We're going to sketch the region of the graph, and then we are going to find the integral of it. So for question C, we've got the integral from -2 to 2 of the square root of 4 minus x squared. Now, the square root of 4 minus x squared is like the equation for a circle if we solved for y, but just the positive portion. So 4 is in place of r, the radius, which means, or not 4, 2 squared is in place of r. So our radius is 2, so from the origin we're going to go out 2 in every direction. And then we're just going to create a semicircle. So we want to find this total area from -2 to 2. So area of a semicircle is going to be pi r squared divided by 2. We know r is 2, so we're going to have pi times 2 squared. So let's just write that as 4 pi divided by 2, which is going to give us, 4 divided by 2 is 2, so just 2 pi square units. So the answer to C is just 2 pi. Now, for D, let's break that one up first. We've got the integral, and as long as there's something that's not in that square root, we can do this break up part. From -3 to 0 of 1 with respect to x, plus the integral from -3 to 0 of the square root of 9 minus x squared with respect to x. So with the first half, we can write it as 1 times 0 minus -3, so 0 plus 3, which is going to give us 3. And then we can graph the second half. It's again a circle, but this time r squared, the radius squared, is 9. So that means the radius is 3. And we're just looking at from -3 to 0. So we're just looking at a quarter of a circle. So we're going to add pi r squared, so 9 pi. But since we're looking at a quarter circle, we're going to divide by 4. So our answer is going to be 3 plus 9 pi over 4. And again, I'm fine with you going and typing it into a calculator to figure out an actual decimal value. And we're getting a little short on time in this video. Instead of putting those last 4 examples in our note packet into a video, we're just going to call it good. If you have questions on this, let me know and I can answer them in class later.